All right. Good evening, Warriors. Good to see you all. Hope you all are doing well. I gotta admit, I worry about some of you sometime. I don't know how you could watch James Hetfield and the crew and not get excited. But, maybe it's inside. You're keeping it inside. So rock on with that. Anyway, here's what we're going to do tonight. First, a reminder about Sunday. Sunday, our last homework is due. You don't have to wait until Sunday, but it's regression. It's on Canvas. So if you're on Pearson and you're looking for it, you have a better off chance looking for last year's Easter egg. It's on Canvas. Check Canvas assignments if you haven't already got into that. And if you haven't started it, then I highly recommend that you take a look at it, especially right after tonight's session. You'll have that fresh in your memory and you should be able to roll into it no problem. And if you have problems along the way, you know how to get hold of me. Throw the signal up in the sky, put up a carrier pigeon, do something like that. All right. With that, let's roll into tonight. This red arrow is where we are. We're into We Drive tonight. We're going to work 3 problems on regression, get our hands dirty, get into the action. I already talked about Sunday when regression assignment is due. Looking at next week, we're going to spend all next week prepping. First on Tuesday, we're going to go not way back, but it seems like a little way back to descriptive statistics. We're going to roll around with that for a little bit, and then we're going to get back, put some more weight on the bar, get some more reps in with confidence intervals, sampling, our friend hypothesis testing, and then we'll close where we are today with a little bit of regression. All right, so no new material next week, only old friends to see again and revisit and get reps in. Looking ahead to next Friday, I will post your classroom interaction and participation assessments. So that'll be online and you'll have everything you need going into final exam week. I'm going to talk about reading day reps here in a minute. And we know the final exam is tears of joy, tears of sadness, maybe no tears at all, but 2 weeks from today. Let's talk about reading day reps. Reading day reps, all times that are on this screen are available. If you want to spend one-on-one time with me on reading day, then you can go ahead and sign up for a slot. Just email me and say, hey, I want the fill in the blank slot. You don't have to. This is entirely mandatory. I'm not keeping a black book and saying, hey, this person signed up for reading day reps, so I'm giving them extra credit. It doesn't work like that. You don't have to wait for reading day reps either. I still have office hours. I still have that. If you want to get on Zoom, work through some problems, get unstuck, you know how to get a hold of me, please do. I would actually recommend earlier than later so you get that stuff imprinted in your brain and you can do more good with it. Okay, that's what knowledge is all about. Here's our agenda for tonight. Pretty straightforward. We're recording right now so you can watch this later on. We're going to work 3 problems. Before I get into all that, just let me take a quick pause and see if there's any questions out there about anything, big or small, that we want to talk about before we get into the main attraction for tonight. Any questions, anything like that? Anything on anybody's mind? All right, let's roll. Boom. So this packet that you're looking at is on Canvas. It looks just like this. So if you want to do it as we go, that's a great idea. If you want to refer to it later, it'll be there for you. Okay, it's already there right now. I didn't plan this. I'm not that powerful, even if I wanted to be. It's just ironic that the weather is kind of not so great today, but hey, it gets us in the mood. It gets us immersed in the problem. So here we go. My favorite character, Batman, friend of mine, couldn't stand the weather. So let's take a look at the narrative here. I got this typo in here. Despite the countless experts who tell him there is no relationship. Batman highly suspects that there is a relationship between the rainfall in Gotham City and the crime rate. Okay, which intuitively would think, yeah, sure, it gets more dark and rainy and more crimes occur. All right. But again, this is all about getting past intuition, getting into science and dropping that science with defiance. So let's read on. Batman is even more concerned because NASA's experimental weather satellite, the Vaughn, has recently been hijacked and dropped completely off the radar, means no one knows where it is. Now, that if that really did happen, that would be a pretty scary thing, that some terrorist has control of a weather satellite. Okay. That means they could make it snow when they wanted to and do all sorts of nasty things. Batman suspects that the Joker has hijacked the satellite, surprise, surprise, and will use it to manipulate the rainfall in Gotham, causing a rampage of crime spree and chaos. So what Batman wants to do is garner local support by demonstrating the relationship between rainfall and crime. With the help of the Bat computer, Batman gathers the following data. So he's got this right here. On this left column, he's got rainfall by month. We don't necessarily know which month this occurred in. We just know that for each one of these numbers here on the left, it was a monthly statistic. So 4 inches of rainfall in a particular month. And within that month where there was 4 inches of rainfall, he also has a record of how many crimes were committed, which was 45. And with this one, 3 inches, he has 23 crimes committed. So this is all past data that he has collected. He prints it out of the Bat computer. Of course, with all this technology, he probably doesn't print anything. He looks at it on his Bat phone, and we go to town. So over here in this blue box, we have a series of questions. So let's just start off. What is the correlation between the monthly rainfall and the monthly number of crimes in Gotham City? All right. So first we want to think about how we determine that. All right. So Delaney, why don't you start us off? How would we determine the correlation between the monthly rainfall and the monthly number of crimes in Gotham City?
Yeah, so we're going to type equals and then COREL.
Okay.
And then
like
we'll highlight the monthly rainfall row. And then the crimes column as well. And then enter.
Okay, super. So that gives us this correlation coefficient R of 0.981. So Alexis, what does that mean in your own words, that 0.981?
I honestly don't know how to describe it.
Okay. That's all right. Lauren, what do you think? What does that 0.981 mean in your own words?
Does that mean like the more rainfall, the more likely there's going to be more crimes?
Yeah, that they have a strong relationship. Okay, remember that correlation coefficients we can't get any more than 1. Okay, so the strongest correlation is 1, and that's the strongest positive correlation. And then on the other side of the coin, the strongest negative correlation is -1. Okay. And then we could have a correlation coefficient that's in between. All right. So the fact that this is 0.981, like Lauren said, this conveys a very strong positive relationship between the two. And as one goes up, the other one probably goes up as well. Okay. So that's really what that means in plain English. So let's move on to this next question. Batman believes that the Vaughn, remember that's the weather satellite, has the capability of causing 10 inches of rain within a month in Gotham. If this happens, about how many crimes should he expect in the same month? So, Colin, get us started on this. How would we begin to determine this?
So we would have to find the slope and the intercept.
Okay.
So we would just put into Excel equals slope and then the monthly rainfall array and then the number of crimes array.
Okay. So we're on the right track. Which one do we want to put in here first, Colin? Do we want to put in crimes?
No, yeah, the Y.
Okay. So, pun intended, why do we want to put in crimes first and not rainfall?
Because our Y determines the X, maybe. I don't know.
Okay. That's all right. Connor, what do you think? Why do we want to put in the number of crimes in first? Why can't we put the weather in first?
I honestly don't know.
Okay. Carrie, what do you think?
Oh, I don't know either.
Okay. Matt, what do you think?
Well, it's the Y variable.
Okay, so why are the crimes, what makes the crimes the Y variable?
They are the dependent value.
All right. So weather is kind of an extreme example of an independent value. Okay. Meaning that Mother Nature, the way I like to describe it is that Mother Nature wakes up in the morning and says, I'm going to do what I'm going to do. I don't have to rely on anybody's permission. I don't have anything affect me. I'm just going to do whatever the heck I feel like doing. Mother Nature probably has a big die and rolls it and says, hey, I'm going to make a tornado today, and goes ahead and does that. So crimes, if anything, if they do have a relationship, it would be the dependent relationship with weather and not the reverse. Does that make sense? Okay? Because the weather's going to do what the weather's going to do. So to say that the weather is dependent on crimes, that just doesn't make sense. See what I mean? Okay. But this is a very important discussion because, and you all were, kind of like Lionel Richie dancing on the ceiling, maybe not dancing around it, you're definitely in the ballpark. It's very important that we identify what's independent and what's dependent, not just for the sake of getting our formula correct, but understanding what we're trying to do. And sometimes it's a little bit harder to discern. Sometimes we just have to make an assumption and say something is dependent on something else. Okay. So, like Colin said, we want to put our slope in there and we're going to figure out our intercept in the same way. We're going to load those Y's in there first. And we're going to load our monthly rainfall, our X's in there second. Okay, so we got our slope and our intercept. Let's see. Anna Grace, what might we want to do next towards answering this question over here?
Let's see. I would probably find so you have the slope and the y-intercept. You would find the x value.
Okay. So what do we think we might have the x value here?
I would go with the 10 inches of rain.
Okay. That sounds like an x value to me because it looks a lot like 8 and 7, etc. And it's a monthly rainfall. 10 inches of rain within a month of Gotham. Okay. So Ryan Mikowski, why don't you walk me through what I want to do now in order to determine the amount of crimes that might happen in that month?
I think you make a graph and then and then find where X is.
Okay. So something like this.
Yeah.
Okay. I could do that. All right. So I could adjust my x-axis out to 10 and start kind of guessing about what crimes are going to be. But there might be another way. And there's a way I could off this graph. I'll show you that here in a little bit. We will have time to do that. But for right now, what do you think? Alexa, what do you think? Is there another way I could determine how many crimes that go with this 10 inches of monthly rainfall?
You would use the y equals mx plus b formula.
Okay. So Alexa is talking about not that. Where we say y, which is our dependent variable, is our slope, which I've seen called a number of things. We'll just call it m, times our x plus our y-intercept, which is that right there. Okay. So we could either do this on a calculator, which would be fine. We would put in our slope. We would multiply it by 10, like Anna Grace said to do. And then we would add our intercept. We would add negative 21.23 there at the end. Or we could do it right here in Excel by just walking left to right. So if we say our slope times our x plus our intercept. Now, again, I've seen this happen, not quite often, but enough to comment on, where Warriors see that negative intercept and they want to do something differently. They want to subtract a negative intercept. Well, you don't want to do that, because when you subtract a negative number, you're actually going to add the number. So I just follow this right here. I'd take the slope, multiply it by the x value, and then add the intercept. If the intercept is negative, it'll all work itself out. And so I get this number right here, which means about 159 crimes we should expect in this particular month when we have 10 inches of rain. Now, Jenna, let's look at this third question. Why does the question above ask for about how many and not how many? So in other words, why does this question ask for about how many crimes and doesn't just say how many crimes? Why do we have this word about in there? What do you think?
I think because the correlation, it's 0.9814. So it's not necessarily like 100% accurate. So you do have some wiggle room there for the crimes to be a little different than what the slope says.
Okay. I think that's on track. Let me show you here using this. What I'm just going to wax on some theory for a little bit. So it's not just with the correlation, it's the concept of what we're doing. And I talked to some Warriors earlier today, and they were almost great intentions are overcomplicating this a little bit. So they kind of got hung up. Well, they said, well, this value is less, and then it goes up and it's less. And so they wanted to group all this differently. Regression is basically kind of looking at the overall, hey, are these numbers going up? They don't have to be perfectly going up. Don't confuse the dotted line. The dotted line is the equation we just did. And that's like us being way down here and shooting a gun into we're shooting a bullet into the air. And we have all these pigeons that are kind of flying around in this pattern. And what we're trying to do is hit a pigeon that's way out here. Now, are we going to hit that pigeon perfectly? Maybe, maybe not. Probably not than exactly, because it's an estimate. That's the bottom line. This is all an estimate. This dotted line is not actually what's happening. The dots are what's happening. Okay, so the dotted line is our best guess. Okay, and that's why the answer to this down here is about how many and not exactly how many. Because this number here, it's a prediction. It's a guess. It's a guess, not a guess, based on a method called regression. Okay, and like any other forecast, any other prediction, it's more likely incorrect than correct, but it's not a big deal. Like if this was 157, okay, so we were off by 2 crimes. That's not a big deal. Okay, so the short answer is it's an estimate. Now, I don't know if I want to show that now. I won't show it now. Remind me in case I forget to show you something else to do with this kind of thing right here. So if you're confused by the theory, I certainly don't want you to. Just when you plot data like Ryan prompted us to do, and you'll do this on the homework and in future stuff, just see, is the data generally going up? Is it generally going down? Could we draw a line through it, where sometimes it's above and sometimes it's below? The line is trying to take the average distance in between. And if we can do all that, then we can apply regression. Okay. If the lines are all over the place and this thing just looks like a mess, we probably shouldn't apply regression. Okay. So focus on that for now and make sure that that concept sticks with you. Okay. Now, this last question here. Is the monthly rainfall causing the respective crime rate? Justify yes or no. So, Cameron, what do you think about that question? What are your thoughts on that?
I want to say yes, because the more rainfall there is, the more crime there is.
Okay. Let's see who else we got out there. Chastity, what do you think?
Based off of what the graph looks like and the other numbers, I would say yes, but like it doesn't make sense. You know what I mean?
Tim, what do you think?
I mean, are you like fishing for the whole correlation is not equal to causation? So like
Yeah.
they're both correlated, but the rain isn't causing the crime.
That's right. I am fishing. So that is correct. So we really should not, be in the D3M Warriors that we are, we really should try to stray away from saying that the rainfall is causing crime. The difference between saying the rainfall is causing, I mean, we really, really want to. And you walk down the street, you run into 7 people and they'll say, oh yeah, based on that, the rainfall is causing the crime rate. But we really can't say that. We can say that the rainfall is positively correlated with crime rate. Okay. But just because these two things are increasing at the same time does not mean that one causes the other one. Just because the stock market goes up and women's dress sizes are going up doesn't mean that one is causing the other one. It's a ridiculous example, but it's one of the classic examples in D3M to bring home the point that correlation does not equal causation. Okay? So yeah, I am kind of trying to not so subtly drum that into your head. All right? And it'd probably be tattoo worthy, although these days I wouldn't recommend getting a tattoo anywhere. All right. Questions about any of this that we just did before we move on to our second problem? Big or small? All right. We will move on to on the nitro. So check it out. Kenneth runs a local Starbucks. This is actually an inside joke with myself. That's an interesting concept because the Starbucks near me that I go to sometimes, not so much anymore, is on Kenneth Road. Anyway, his regional manager has told him to increase sales. So Kenneth is examining what products sell well together. Okay. More specifically, Kenneth has noticed that despite the cold weather, the nitro cold brew continues to sell well. That's this right here in the picture. Additionally, he suspects that the sales of everything bagels and rice pudding cake pops, try not to throw up in your mouth, may depend on the nitro cold brew sales. Okay, so there we have some information about independent and dependent. For a week, Kenneth collects sales of the nitro, the everything bagel, and the rice pudding cake pop. And Kenneth didn't work on Sunday, so we have 6 days of data. So the way that we read this is where my cursor is right now, let's just say is Monday. It could just as easily be Friday. It doesn't really matter. But on that particular day, this Starbucks sold 435 nitro cold brews. And at the same time, on the same day, they sold 400 everything bagels. And also on the same day, they sold 67 rice pudding cake pops. So that's how we read this table. Okay. So what is the correlation between nitro cold brew and the rice pudding cake pop sales? All right. So let's see here. Travis, how do we get started on that question right there?
Would you do correlation or equals correlation, and then would you select the nitro and the cake pops?
Yeah.
Okay.
So I'm just going to do that right there. I can hear it in your voice. You're like, it's almost too easy. Yeah. Nothing. Remember, we're petting a bunny tonight. There's nothing difficult about this. I'm actually going to move this over because I'm going to make a little quasi table over here. So this is my R, and this is between my nitro and my RPCPs. All right. So it's a negative 0.93. Carrie, what do you think about that correlation coefficient? In your own words, what is that kind of telling you?
That it's a strong negative correlation.
Right. Which means what?
That I don't know.
Okay. That's all right. Well, we could do this right here. There's probably a faster way to do that. While I'm doing this, Nick Hager, what do you think is the independent variable and what is the dependent variable between these three?
Wouldn't the dependent variable be the, well, you're asking for like the y, right? Wouldn't y be the rice pudding
Yeah.
and the
And
x would be the nitro?
Yeah, exactly. Very good. So one thing I could do is I'm just going to pull this down a little bit. All right. If I wasn't entirely sure, if I wanted to get more sure, so I could do a little scatter plot of these two. Okay. And because Nick just told me that my independent variable is always on my x-axis, that's why that is. It's not everything bagel, it's nitro, so don't get confused. Don't let me confuse you. But these numbers down here are my nitro, and these are my rice pudding cake pops. So as I sell more nitro, I sell less rice pudding, cake pop. Okay, so that's what that negative correlation means. That's what that negative 0.93 means. As one goes up, the other one goes down. Okay, or as I sell less nitro cold brews, some weird way in the world, I sell more rice pudding cake pops. Okay, so let's check out the correlation. Question number 2 between nitro and everything bagel sales. All right. So I'm going to just cut to the chase on that. Same method. Nitro, everything bagel. Do my little correlation action. I'm gonna load my nitro in there. And my everything bagel. 0.842854. Or just to be simple, 0.84. That means that if I graph those, and I can grab those right here, I should expect to see as one goes up, the other one goes up. And sure enough, they do. That doesn't want to move up there for some reason. Does it go here? Okay. All right. So strong positive correlation, 0.84. Strong negative correlation, negative 0.93. Okay. All right. What else? Kenneth learns that the YCP Warrior Nation, that's you all, will flood his Starbucks over the next week, demanding nitro cold brews. Therefore, he predicts nitro sales is about to shoot to 900. Okay. Assuming they cost the same, would it make more sense for him to stock everything bagels or rice pudding cake pops? And then justify your answer mathematically. So you might have an intuitive reaction to this. So let's see here. Delaney, what's your intuitive reaction before you start rolling with some math? What do you think it would make more sense for him to stock? Everything bagels or rice pudding cake pops? Delaney, you out there? I think we lost her in the storm. What do you think, Alexis?
I would say everything bagels
Okay. Why do you say that?
because more of them are being sold. Or if you look at the graph, both are increasing or it's increasing.
Yeah. So if I just look at my graph, like Alexis said, and I look out here to 700 and I go up here, well, that's going to be a high number. I don't know exactly what it is. We're about to figure that out in a minute. Okay. So I take this dot right here, which isn't 700, but it's pretty close, and I can track it back here. Or I look down here. I think that dot refers to 666. What an evil number. And I had 525. So compared to 42 rice pudding cake pops. So intuitively, without even doing the math just yet, we could kind of guess that everything bagels is the pick. But being D3M Warriors, we want to take it one step farther. That's that beautiful drop signs with defiance part. And we want to go ahead and figure this out. So, Matt, why don't you get us started? How do we figure that out? How to answer this question? Matt, I don't know if you're talking. You're on mute, though.
Oh, sorry.
That's all right.
Well, it would make more sense to stock the everything bagel, correct?
Well, that's what we think, but we want to make our answer bulletproof.
It's a positive correlation between nitro and everything bagel. Whereas the nitro versus the rice pudding cake pop is a negative correlation.
That is true. So what I would like y'all to do, and all these are correct, but to be bulletproof, I would like you to do this. Okay, so there's that magic 900. And we're going to figure out, using this regression model, what kind of answers we would get down here. All right. So, Connor, how do we get this answer where my cursor is right now? How do we figure out that value?
Well, you're going to have to find the slope between nitro and everything bagels and the intercept as well, and then plug that in.
Okay. So again, I'm going to put my everything bagels in first because those are the dependent values. And I'm going to put my nitro in second. And then I'm going to figure out my intercept, just like Connor said. Same. Bagels in first. Y is in first. And then my nitro stuff in second. Okay. So I have my little handy dandy kind of makeshift table down here that I'm making on the fly. And so then I'm going to figure out this value by taking that slope, mx plus b, multiplying that by our x value, and then adding our intercept. Lauren, what do you think that number is going to be? Just guess. Don't try to get it perfect. Just guess. What do you think it's going to be?
Probably around like 700.
Around 700?
Well, like when you do the y equals mx plus b, the final probably be around like 700 maybe.
Okay. So,
or 900.
Yeah. So Lauren's probably cheating, looking at this graph. Not cheating. She's using what she's got. And just under 700. So pretty good guess. All right. So pretty high. All right. And then to figure out this value in the blue, we're just going to do the sister of the process over here. So we're going to figure out the slope of this line that runs through these values. And we're going to do that by putting these rice pudding cake pops in there first. And then the nitro values. And then we'll do the same with the intercept. Okay, Nick, before I hit enter, what do you, just ballpark figure guess, what do you think this number is going to be?
Wait, let me look at the graph. It's probably going to be like less than 20.
Less than 20. Well, that number, I was asking for the wrong number. So let's see. Same process, mx plus b. But Nick was thinking of the right number I wanted him to. I just was in the wrong spot. Is my bad. And then we add that intercept. Here we go. Nick says less than 20. It indeed is less than
way
20.
less than 20.
9.97. So, assuming that we're charging the same amount for everything bagels, like let's just say $2 per every single everything bagel is $2, and then for some weird reason we sell the same, charge the same for a rice pudding cake pop, $2. Alexa, which one should we sell alongside the nitro cold brew?
The everything bagels.
Yeah, because we're gonna make a lot more money. We're gonna make a ton more money. Whatever, 700 times 2, 1,400 times this piddly little 10 times 2. Okay, so that by that process, we can answer this question here. We can really drive it home. And we still have, I don't want to say we have doubt. This is still a predictive model, but we can now answer this question in the best manner. Okay. Questions on this question, big or small, anything that we just did. All right, we got one more and then some bonus stuff. So it wouldn't be complete if we didn't talk about Batman one more time. There's always more time to talk about Batman. So, Couldn't Stand the Weather Part 2. Batman believes the Joker will use the Vaughn. That's that weather satellite that the Joker has hijacked during a month with already high rainfall in order to cause havoc in Gotham City. Okay. So Batman's trying to figure out what month this might be. And so he goes to the Bat computer. He gets the Bat computer to spit out some data. So what we're looking at is in the month of November, we had 2.5 inches of rainfall and so on and so forth. All right. So our first question is, what is the correlation between the month, any particular month, and the amount of rainfall in Gotham City based on this data that we have here? So, Colin, how do we answer that question?
We can do the correlation thing, but we have to change the months to numbers. So the November will become 1, December will come 2, January will come 3, 4, etc.
Okay, outstanding. So like Colin said, we can't enter these into Excel. I'm just going to leave them there and gray them out so that you all will still know that this is November, and I will too. But like Colin said, I'm going to add my time periods over here. Okay. All right. And then I can do correlation like I always do, which is to grab, and that's what Colin said. I can grab one array. I'm not going to grab this array because it's just not going to make any sense. I'm going to grab this array. Boom. And I have a correlation coefficient of 0.97. Okay, so by now we know 0.97 means a strong positive correlation. As months increase, okay, in this sequence, the rainfall goes up. And I don't know what happens when I plot this. I should know. I don't think it's going to give me what I want. No, it doesn't. So I'm not going to do that. I'm just going to do this right here. I wanted to keep that November, December thing down here. I know there's a way to do it. I just am not going to waste your time with it right now. It still doesn't do that. I don't like that. I'm just going to, Excel just wants to play games with me in front of you guys. And will that do it? Yeah, so that makes it look a little bit cleaner. Okay. So again, my purpose of doing that is I see that as my time period goes on, that so does my rainfall goes up. Okay. Now, already intuitively, I know that I can only run this model for so long because rain just doesn't go up constantly throughout the entire year. At some point, it probably drops back down. So I know I have a limitation out there somewhere. I'll just put that in the back of my mind. But for now, the next question I want to answer is, what is the predicted amount of rainfall for April? Okay, so let's see here. Anna Grace, you want to give that one a shot? How do I figure that out?
The predicted rainfall for April.
Mm-hmm.
Let's see. I would start with figuring out what the slope is.
Okay.
So that would be um hmm.
We're definitely on the right track. What do I want to put in there first?
You would want to put I'm trying to remember the variables, like which one goes first.
Yeah, so Anna Grace is on to a really kind of like the $1 million question at this point, and we
This
have
always trips me up, like the independent versus dependent variable.
yeah. So both of these kind of seem very, very independent. I think out of the two, we're going to put rainfall as dependent on the time of year.
That
Okay.
makes sense.
So we'll put that rainfall in there first, and then we'll put these time periods in there. All right. And
Okay.
then we'll do the same thing for intercept. Put that rainfall in there first. Boom. Put that time period in there next. Bam. And just so everybody's clear, in this instance, we're assuming that time period is our independent variable. Time of year is going to just happen. It's not really dependent on anything. But the rainfall in terms of when it occurs in volume might be dependent on the time of year. Okay, so that's a safe assumption to make. So out of that, with like Anna Grace said, we identified slope and intercept. Okay, so Tim, what's the next thing we might want to do to answer towards answering this question? How much rainfall should we expect in April?
I mean, you would set up April underneath your chart there with a 6 beside it, because April's the 6th in this chart we have. And then do your formula.
All right, so everybody noticed that Tim correctly did not put April with a time period of 5. So in his mind, Tim went ahead and created that space essentially by putting March in there and putting this number in his mind. All right, he didn't share all that with us, but that's essentially what he did because he correctly identified this time period. So the bottom line is don't get tripped up. I don't wake up in the morning to trick you, but the strength of regression is that we can skip over time periods. And with my limited experience with forecasting models, regression is the only model in which we can do that. Other forecasting models, and for those of you who, if we do another tour in the War on Knowledge together and operations, we'll explore those models together. But with those other models, we can't skip time periods. But with regression, we can. So anyway, we go back down here. Like Tim said, we're going to grab that slope. We're going to get that X value 6, and we're going to add that intercept on the end, which takes us to 8.89 inches. Okay, looks like it makes sense in conjunction with everything. Okay, super. Let's go on to this question. The back computer states, and I don't know how familiar you are with the back computer, it can kind of answer questions kind of like Siri on steroids, something like that. The back computer states that the predicted amount of rainfall for March will be 7.2 inches. Should Batman have the back computer recompute this prediction or go with it? Justify your answer. What do you think? What do you think, Ryan? You think 7.2 is a reliable prediction for March? How can we make sure that it is?
I think it seems accurate, but like, I mean, like, yeah, it seems accurate. I mean, he could double check it.
Okay. How would we double check it?
You'd use the same slope and y-intercept except you would use the 5, or yeah, you'd use the 5 instead of the 6.
Okay, outstanding. So we'll just go ahead and throw that in there just to be sure. Ooh, 7.6. So we probably want to tell the back computer, hey, do this again. Okay, because we have a regression model, and heck, after all, the back computer gave us all this other data. This seems kind of like a glitch kind of thing. And then finally, Chastity, is the particular month, pick a month, causing the amount of rainfall? Justify yes or no in your answer.
No, because I answered yes last time. No.
That's one way of putting it all together. Hey, I'll take it. Like we said, just because they are increasing together does not mean that it is causing it. Okay. And like Chastity said, correlation does not equal causation. All right. And we want to do that so many times in life. But you can use this in various ways. You can I can think of some nefarious ones, but then you'd say, hey, Dr. Shatskin told me to do this, and then I might get into some trouble. All right. Questions on anything we have done with this problem, big or small? Okay, let me show you something. We have a tiny bit of time. I'm not just trying to fill time, but I had this question in my other section, and so I want to share this knowledge with you. And like anything else, remember when we first started talking about regression, I said, hey, there's more than one way to figure out slope and intercept. And if you remember that, I also said, I'm going to show you this way because I think it's a very simple way. And I honestly believe that my job when I wake up in the morning is to show you simple ways of doing relatively complicated things, not the other way around. Okay. There is more than one way to determine slope and intercept. And so somebody asked me about this earlier and said, could we use this way? And because I said yes to them, I want to show this to you. Like everything else, though, if this confuses you or you don't feel comfortable with this, just because you pick a flamethrower up doesn't mean you should use it. Okay? Or a circular saw for that matter, because you could hurt yourself. So if you don't feel comfortable using this, what I'm about to show you, then stick with what you know and what we've done. All right, check it out. I'm going to try to get this as big as I can so that you can see it. All right, so I have my data plotted. Another way I can find out the slope and the intercept is to first left click on any one of these dots. Just pick one, it doesn't matter. And then I right click. And I'm going to go down here to, I could first add that trend line. And that's that shotgun that I'm shooting skeet. I don't know. I'm talking way out of what I understand. But I'm shooting to try to hit that point either out here or somewhere in between. That doesn't tell me the slope and the intercept, though. It kind of puts things in context. If I choose format data series, watch the right side of my screen over here. Come on, baby. Where is it? Why is it not showing up? Should be. Okay. I guess you got to do the trend line. So add trend line. And see all this stuff that shows up? Don't worry about all that. But go down here to where it says that display the equation on the chart. All right. And you want to check this box. And see what happens. This little bitty thing just kind of pops up over here. I'm going to make it bigger so that you can see it. You can make it bigger by just going up here to your font. Boom. Right there, you got slope and intercept in one shot. My slope is 1.29. My intercept is 1.15. And that matches what we found out the other way. So if you want to do it that way instead of this way, you can. I'm not going to tell you you can't. For those of you that go on with this stuff, QBA 265, they do a lot of work like this, as well as other ways. So this is certainly not incorrect. And if you do this on an exam or homework or stuff like that, I'm fine with that. I didn't show it to you, not because I'm hiding stuff, but because I'm going, again, what's the simplest way that I can communicate a relatively complicated concept to you all so that you can remember it? And so I choose this way right here. But you have this now. You have another weapon in the arsenal that you can choose. Just know what you're looking at, okay, when you do that. Any questions on what I just did? What we just did? Okay. That is all that I have for this evening. What I'm going to do is I'm going to save this file here and post it. I also have the answers without the work we did tonight, so you can look at either one. You'll also have this video, which I'll post 15 or 20 minutes, as long as it takes to upload. So you'll have that to refer to as well. As always, I will stay until we clear the call. If we have follow-on questions, things that people want to talk about, I will talk until there's no one left. Otherwise, if you are moving out on the homework and you get stuck, please email me, get hold of me, and we'll get you unstuck. If I don't talk to you, have a great weekend, and we'll see you on Tuesday.